Laterals that we know things about. So, today we're talking about the shape that has exactly one pair of parallel sides. If it only has one pair of parallel sides, is it a parallelogram? No. Parallelograms, by definition, have two pairs of parallel sides. So, what that means about this shape is that this shape does not hold the parallelogram properties. It does not necessarily have opposite sides congruent, opposite angles congruent, consecutive angles supplementary, and diagonals bisecting one another. It does not hold those properties. This one stands out as different. What is the name of this shape? Y'all remember when it looks like that? Starts with a T. It's a trapezoid. ABCD is a trapezoid. If AB is parallel to CD. Ooh, that reminds me. Do I have a typo on my postulate sheet? Nope. Sweet. So, one pair of parallel sides makes it a trapezoid. Now, when it comes to a trapezoid, a couple things we have to know. Those parallel sides are known as the bases, while the non-parallel sides are known as the legs. So, in this trapezoid right here, that's base, that's base, this is a leg, this is a leg. So, parallel sides, bases, non-parallel sides, legs. Now, we also have what are known as base angles. Now, base angles are angles who have a common side between them that is the base. This is a pair of angles. So the two corners of the trapezoid that are on the same base are called base angles. This is a pair of base angles, and this is a pair of base angles. Now this is important because of what it leads into with a very specific type of trapezoid. Specifically the type of trapezoid that you're most likely to have seen in the past. And that is a trapezoid in which the legs are congruent. It's known as an isosceles trapezoid. In an isosceles trapezoid, it will have not only congruent legs, but congruent base angles. I don't remember who put it on my desk, but someone found it. Thank God. So, this trapezoid right here, and I know it's a trapezoid because it has just one pair of parallel sides. It is an isosceles trapezoid if AD is congruent to BC, which is already marked on here. But we're also going to have angle A congruent to angle B because those are two angles connected by the same base. And the other pair of base angles is also congruent. Angle D is congruent to angle C. Now this allows us to do different things with solving. And so that's one of the things you're going to see here. So this is going to allow us to do some solving. Now there's one other theorem that we're going to use. Now this theorem is specific to isosceles trapezoids. Regular trapezoids this will not work with. But in an isosceles trapezoid, the diagonals are also congruent. So AC is congruent to BD in this isosceles trapezoid. And in fact, this is actually a feature that can force something to be an isosceles trapezoid. Hence, it's the if and only if. Who's your second teacher? Okay. Yep, I will make you your pass. So, we're going to come across a couple different types of problems today. First one. AD is equal to x plus 2. Is AD a side, a diagonal, part of a diagonal, or an angle in this picture? It's one of the legs, so it's a side. Specifically, it's that leg, x plus 2. BC is 2x minus 12. Again, angle, side, diagonal, or part of a diagonal? It's a side again. Specifically, it's the other leg. 2x minus 12. BD is 2y plus 8. Side, angle, diagonal, or part of a diagonal. BD, corner to corner, not right next to it, all the way across, that is a diagonal, which is not easy to mark on the shape, so I just draw an arrow to it, say, hey, that's diagonal. What about AC? Because AC is 8. Also a diagonal. In an isosceles trapezoid, we're working with legs, we're working with diagonals. What do we know about the legs in an isosceles trapezoid? They're congruent, and congruent means they are equal. Those two are congruent. And I can tell that by just the markings on the picture. X plus 2 equals 2x minus 12. And we can solve for x. 2 equals x minus 12. Add the 12. 14 is equal to x. In other words, x is equal to 14. Is that what it's looking for me to solve for? What do the instructions say? Solve for the variables. Is x a variable? Yes. Yes. Is it the only variable? No. So I'm not quite done, but that is one of the things it's looking for. I also want to solve for y, because y is also a variable here. Now y is sitting in a diagonal. So now, what do we know about the diagonals of an isosceles trapezoid? The diagonals are also congruent. So 2y plus 8 is equal to 8. Minus 8 from both sides. 2y is equal to, if that cancels out and that cancels out, what's left over here? What is nothing as a number? 0. One of the things I've noticed is when you get zeros in the problem, people get tripped up. They think something's wrong with the problem. It's not necessarily wrong, just sometimes things are 0. Divide by 2, what is 0 divided by 2? Still 0. Okay. Next problem. I'm given the measure of angle E is equal to 2x plus 12, and the measure of angle G is 3x plus 18. Those are angles, and they're corners. They're full corners of my trapezoid. This one being the 2x plus 12. This one down here being the 3x plus 18. This is an isosceles trapezoid. What do you know about angles in an isosceles trapezoid? Well, this is about trapezoids, but those aren't angles. Not helpful. This is about isosceles trapezoid. I got some angles in here, don't I? Base angle pairs are congruent. That's a key about this theorem. Those ones are a pair of base angles. These ones that are congruent are also a pair of base angles. Are the angles that I have marked base angle pairs? Now, base angle pairs would be like that one and that one. Or this one and this one. So I know angle E is congruent to angle F. I know angle H is congruent to angle G. But it only gives me limited information. Means I could mark this one as 3x plus 18. It means I could mark this one as 2x plus 12. From there, there are a couple different options on how to solve it. Yes, ma'am?
Go back to the beginning of our note sheet. We have this thing that equals the interior angle sum or whatever.
So one option is that, the interior angle sum. This is a quadrilateral. It's got 4 sides. We could do the 180 parentheses 4 minus 2. It's not the easiest way to do it, though. It is something that can work for us, but it's not going to be the easiest way. There is one other way. And this other way will actually work for all trapezoids, which is why I want to focus on it. Nate, if you wanted to do it that way on an isosceles trapezoid, go for it. But for a non-isosceles trapezoid, that will not work because the base angles are not congruent. The other thing we can use to our advantage, because we have parallel lines being cut by transversals. These two angles right here, they are between the parallel lines. They are on the same side of the transversal. That makes them consecutive interior angles of parallel lines. What do you know about consecutive interior angles of parallel lines? They are supplementary. In a trapezoid, and now we're going to write a little note to self so that we know this for all trapezoids. In any trapezoid, the angles connected by a leg are CIA and therefore are supplementary. This will create smaller problems to work with. What does supplementary mean again? Add up to 180. Nope. So, these two will add up to 180. That one is 2x plus 12. Plus, what's this one? 3x plus 18 because it's congruent to this one. Two angles together, added together, equals 180. From here we solve. Combine my like terms. In other words, simplify. I get 5x plus 30 equals 180. Subtract the 30. I get 5x is equal to 150. And then divide by 5. X equals 30. So sometimes we have to use other features, such as parallels, to work with trapezoids. But it's a very specific situation that you use that, and it's really just this one. If you have two angles connected by a leg, they are supplementary. Okay, there's one other theorem we're going to talk about with trapezoids, and it is the trapezoid mid-segment theorem. The mid-segment of a trapezoid is parallel to each base, and its length is 1/2 the sum of the lengths of the bases. Okay, so that gives us a couple things. First off, we need to know what a mid-segment is. What a mid-segment is, it's a segment that literally goes through the middle of each side. So this is my mid-segment. And in order for it to be a mid-segment, that means this and this are congruent, because this has to be the midpoint. And it means this and this are congruent because this has to be the midpoint of that side. Now that's just what makes it a mid-segment. Now a mid-segment is parallel to the sides. In a trapezoid, these are naturally parallel. The mid-segment is also parallel. So, XY is the mid-segment if AB is parallel to DC, which is parallel to XY. But there's the more important piece out of this. The length of one of the mid-segment is 1/2 the sum of the lengths of the bases. That's going to be the more important thing that we use. So the length XY, that is the length of the mid-segment, is equal to 1/2 parentheses, the bases added together. The bases are the parallel sides. So in this case, AB plus DC. With mid-segments, that's what we're going to focus in on, is using that formula. And that's what's showing up on the last page. Find the missing, or the length of the missing segment if HJKL is a trapezoid and MN is the mid-segment. Now, first one, HJ is 32, LK is 30, find MN. Which of those three is the midsegment? HJ, LK, or MN based on the picture, based on what it says above? MN. Would you also agree that it is the one length that we do not know? Do you notice that there's not a variable involved in this problem? There's no x's or y's either. When there's not a variable involved, if there's something you don't know, that's when you can put a variable on. If there's already x's and y's and all that being used, you can't put x's and y's on things. But in this case, there's no x's and y's, so I'm going to say, okay, mn, we're going to set you equal to x. Because that's the thing we don't know. Now, according to my theorem earlier, xy equals 1/2 ab plus dc. xy was the midsegment. In this case, mn is the midsegment, which means my formula is going to start with x equal to. Then it says 1/2. And in the parentheses, it had ab plus dc. Those were the bases. In this case, my bases are 32 and 60. And so I plug in what I know into that formula. And if you prefer, this formula sometimes is easier to work with in words. So I'm going to write it up here in words. Midsegment equals 1/2 base plus base in parentheses. That's what the formula essentially is in words. Now I want to solve for mn, which is what we called x. So we're going to solve for x and call it mn. I want to solve this. What do? Add and then multiply by 1/2. What is multiplying by 1/2 the same as? Finding half of something is like dividing by 2. So if you prefer to do it that way, you can, or you can multiply by 1/2. Either way, we start with the 32 plus 60. 32 plus 60 is 92. Half of 92, that's what calculators are for. If you need to grab a calculator, get one. What is half of 92? 46. X equals 46, or more accurately, it wasn't actually x in the first place, it was mn equals 46. The hardest thing about doing this is just making sure we're putting things in the right spot. Midsegment goes where the midsegment has to go. The bases, it doesn't matter which one goes first, you just have to choose a base in each spot. Problem B says if HJ is equal to 18 and MN is equal to 28, find LK. LK is the thing we're missing, so I'm going to set it equal to X, because X isn't being used. Which of these is the midsegment? HJ, MN, or LK? MN. I need to know which one is the midsegment, so I put it in the right place in the equation. My equation starts with midsegment equals. So in this case, we're going to write what equals? 28 equals 1/2. In parentheses, base plus base. Is HJ a base? Is LK a base? Yeah, X. And now we have our equation to solve. This one solves a little differently. If I want to solve this, what do I have to do? Distribute. I have to distribute the 1/2. I get 28. I wrote way too big. Equals 1/2 times 18? 9. Plus 1/2 times x. 1/2 x. I want to solve for x. Do I get rid of the 9 or the 1/2 first? 9. Undo the adding and subtracting first. The numbers in front of x go last. Subtract 9. 28 minus 9 is 19. 19 equals 1/2 x. How do we get rid of the 1/2 in front of it? By what?
19.
No. How do you get rid of a number in front of a variable typically? What if it was a 2x? How would you get rid of the 2? No. Divide. You would divide by it. Does it change just because it's a fraction? Technically, no. What is 1/2 as a decimal? Would it be easier to divide by 0.5 than to divide by a fraction? If you choose to divide by the 1/2, you can, but it needs to go in parentheses when you put it in your calculator. 19 divided by 0.5 is 38. If I did 19 divided by 1 divided by 2 without a fraction, I'm going to get a different, or without parentheses, I'm going to get a different number. If I put it in parentheses, it's fine. Otherwise, there's one other option. To divide by a fraction is the same as to multiply by its reciprocal. Does that sound familiar? The other option was to multiply by 2. As long as I use the parentheses, I get the same thing regardless. X equals 38. But it wasn't x, it was LK. When you put the x on the problem, you should always change it back to what it was. Okay, we got one more like this, and then the last two change it up a little bit. If Mn equals 23 and KL equals 45, find Hj. I don't know Hj. I'm not using variables. I'm going to set it equal to x. Which of these is the midsegment? The 23. From here, I want you to try the problem on your own. Who's your second arm?
That one.
John, I need to teach you. Can't just stand it. Okay. I already did the problem. So the moment I touch the board, it's going to show you. So I'm just going to move it out of the way. So we were given that MN was 23, that KL was 45, and that HJ is what we're looking for. So we set HJ equal to X, and we say that MM was the mid-segment. If MN is the mid-segment, the formula says mid-segment equals 1/2 base plus base. Which number do I start with? 23, 45, or X? 23, that's the mid-segment. Equals 1/2. Doesn't matter which goes first between the X and the 45. Or do I just put them both in for bases? Just put them both in. Doesn't matter which one goes first. I distribute. What is half of 45? 22.5. Half of X is 1/2 X. Or if you prefer the decimal, what is half as a decimal? 0.5. What's 0.5 times X? 0.5X. If the fraction is messing with you, change it to the decimal 0.5. Subtract 22.5. 0.5 is equal to 0.5x. How do I get rid of this 0.5? Divide by it. 0.5 divided by 0.5? 1. X is equal to 1, but it wasn't actually X, it was HJ. It's equal to 1. Mid-segment? Because the instructions explicitly say MN is the mid-segment, on this one, yes. Is MN always going to be the mid-segment? No. The mid-segment, Zion, is the one that does this. So that's why that one's the mid-segment, is because of the fact that it's going through the middle. These ones are just happen to be set up that MN is always the mid-segment. Okay. Sometimes the problems might get a little more complicated but do the same thing. MN is still our mid-segment. MN is equal to 2x plus 4, HJ is 12, LK is 28. You identify your mid-segment, which on this case is still MN, and we plug into that formula the same way we did, even if the problems are a little more complex now. Mid-segment equals 1/2 in parentheses base plus base. MN is the mid-segment. Is HJ a base? Yep, it's one of the parallel sides. Is LK a base? Yes, it's one of the parallel sides. 12 plus 28. From here we solve. Do you notice that the entire right side is all just numbers? There's no variable involved. If that's the case, we do PEMDAS with it. I do my parentheses and then I multiply by the 1/2. 28 and 12 added together is 40. And 1/2 times 40 is 20. Once it looks like this, I know y'all know how to solve. minus 4, 2x equals 16, divide by 2, and x is 8. These ones just want you to solve for the variable though, specifically x. The only difference is going to be what those solving steps look like based on what the question looks like. Our final problem. Mn is equal to 14, Hj is equal to x plus 12, and Lk is equal to 3x minus 6. Which of these is the mid-segment? Because the mid-segment is still Mn in this. So, that's my mid-segment. Cam, how am I going to start the equation? Something equals. What goes before the equal sign this time? The mid-segment, so yeah, 14 equals. Haley, hurt. What's going to start over here? Don't forget the 1/2. It's one of the most common things I see as a mistake. Parentheses. Aaliyah, what should I start putting in those parentheses? I can't hear you. Can you repeat that? X plus 12 plus 3x minus 6. Doesn't matter which order those ones go in. They are the bases. I want to solve this. Peyton, what's the first thing you think I should do when solving this equation? Combine the like terms in that parentheses. Add together what you can specifically. X and 3x is 4x. 12 and negative 6 is a positive 6. (14) equals 1/2 parentheses 4x plus 6 is what we got. Jada, what should I do now? Distribute the 1/2. In other words, multiply the 1/2 through. Half of 4x, 2x. Half of 6, 3. 14 equals 2x plus 3. Now this is the type of solving we tend to like to do. Subtract the 3. 11 equals 2x and divide by 2. X is equal to 5.5. Is that what the question wanted me to solve for?
I think so.
Yes, it said find x. If it asked me to solve for one of the side lengths, could we plug it back in?
Yes.
Yeah. Guess what? I got a worksheet for y'all. Make a pass, guys. Make a pass after Mariam. Yes. After Ari.